Hello, grade 11s. I want to do a few examples for you on names and formulas that you're going to find in your green workbook on pages 22 to 29. So on page 22, let's work on one or two of these together. And let's start by going with a name for the very first one you find on the page, NAI. So the first question you're going to want to ask yourself, is this ionic or covalent? Which set of rules are we going to follow? We tell by looking at the first element listed. Is it a metal? If it's a metal, we automatically go with ionic rules. Now, when it's ionic rules, it's first name ends in "ide." So first name is sodium, last name is iodide. Then we have to ask ourselves, do we need a Roman numeral? Well, is sodium a transition element? No, it's not. So no Roman numeral is needed. Let's try another one on the same page. Let's try doing a formula for aluminum chloride. So down at the bottom of the page, we have the element aluminum chloride. When we do formulas and we have a metal present, we use the symbols, charges, crisscross, reduce method. The symbol for aluminum is Al. The symbol for chloride, Cl. Aluminum's charge is +3 because it's in group 3 on the periodic table. Chlorine's charge is -1. When you do the crisscross, what I'm asking you to do is take just the number and put it down and to the opposite element. So now we're going to have Al with a 1 after it and Cl with a 3 after it. Of course, we never write the number 1 in chemistry, so we just get AlCl3. Turn your book and take a look at page 23. At this page, we see that there's Roman numerals. And Roman numerals are used anytime we have elements that commonly have more than one charge. So that would include all of our transition metals in the middle, as well as tin and lead, who act very much like transition metals when they form bonds. So let's try the very one at the top, iron 2 oxide. The reason we use Roman numerals in a name is because you never ever will see numbers in a name. And technically, Roman numerals are letters. This is still a metal, non-metal, so we still use ionic rules. So iron, symbol is Fe. Oxide is from oxygen, symbol is O. The charge on iron is +2. The charge on oxygen is -2. How did I know the charge on iron was +2? Because we used Roman numeral 2. And the Roman numeral is the charge that it took. So when we do the crisscross, this 2 goes here and this 2 goes there. You make an X with it. We would now write this as Fe2O2. And in this case, we can reduce. Both these numbers can be divided by 2, and we can reduce this to the form FeO. Let's try one from the bottom of the page. Again, I know this is an ionic compound because lead is a metal. So it'll be first name last name ends in I. Pb is lead. O is oxygen, so it'll end in oxide. Then I have to ask myself, anytime I do a transition or ionic compound, I ask, do I have a transition metal? And yes, I do. So the lead has to come with a Roman numeral. We'll put it in brackets. How do we figure it out? Well, I'm going to show you two ways to do it. Let's start with a drawing way. In the formula PbO2, I see one of the lead, so I'm going to draw one lead atom, Pb, and I see 2 of the oxygen atoms. I'm going to draw 2 of the oxygen atoms. Here's my 2 O's. We know the charge on oxygen is always -2, so I'm going to put 2 minuses in each of these O's. I have a total of 4 minuses here. How much positive will it take to cancel that? Because compounds are always neutral. They have no charge. Well, I'll have to have +4. Since there's only one lead here, all 4 positives go inside that lead. And this is lead whose charge is 4. I'll use the Roman numeral 4 because we don't use numbers in a name. Lead 4 oxide. But there's another way to think about this. If you prefer to think in terms of math and numbers, you can see I've got one lead at whatever its charge is, and I have 2 oxygens times whatever their charge is. We know the charge on oxygen is -2, okay? We have to figure out what the charge on lead is. But I also know that whatever the charge on lead is, plus the charge on whatever all the oxygens are, must equal 0, because there's no charge on a molecule. 2 times -2 is -4. This value would have to be +4. The only value that fits in the blank is +4. And again, this is lead whose charge is 4 oxide. So there's 2 ways to think out how to solve for your Roman numeral. Let's do one more example. This time we're going to do one from page 24. Let's try the example to do N2O5. In this example, there's no metals. So we can't follow ionic rules. We have to follow covalent rules. We still do first name, last name ends at I, but something happens a little different. First name for N is nitrogen. First name for the O, or last name for the O is oxygen, but it'll end at I. Change the ending to IDE. But we can't use crisscross rules for covalent if they don't work that way. So we use prefixes, and the prefixes are just straight up say how many we have. I have 2 nitrogens, so I'm going to tell us that we have 2 nitrogens by using the prefix di. I have 5 oxygens, and the prefix for 5 is pent, or penta. So this would be dinitrogen, pentoxide. You notice there's no crisscrosses. We just plain out tell you what we have. On the bottom of the page, we'll pick the example sulfur dioxide. So sulfur symbol is S. Oxide comes from oxygen. That's an O. I can see that I have dioxide. That means 2 of the oxygens. So the place where we say how many is down and to the right. There is no prefix in front of the sulfur. That's because the rules say we can't start a name with model. We can start with any other prefix, but never model. So we're going to assume there's only one of them. And since we don't have to write the number 1 in chemistry, we'll just write this as SO2. Hopefully these examples help you to work through your problems in your workbook on names and formulas.